Will be open at noon, so you cannot go there at this time. And also that we are still accepting some lightning talk proposals. So find your courage and propose something. And then if you want to make some question to our speaker, you can always use Slido. There's the dedicated Slido for this room, so it's available to you. All right, so now we have the talk Modern Observability for Python. Observability is changing. Gone are the days of plain text logs. We've now got traces, metrics, observability infrastructure, and multiple standards for all of them. Join us to learn what this all means and how you can use this new technology to gain visibility into your project. This talk is by Adrian here. Adrian is a maintainer of Starlet, Uvicorn, Pydantic, and a contributor to FastAPI. A lot of stuff. Thank you. He has experience in managing and designing large-scale data system, observability platforms, and infrastructure. Welcome in. Thank you.
Thank you, everyone. There's a really full room. This is really amazing. I'll give just like a little bit about myself that makes me really happy to be here. My family's originally Italian. I grew up in Argentina. I speak English, Spanish, and really terrible Italian. But it's really cool for me just for my heritage to be here. And like, you know, I'm sure my great-grandfather would have never thought I'd be presenting at a Python conference in Italy. So I'm going to talk to you today about modern observability for Python. The idea is that we're going to start a little bit with a history of observability and end up like at where we are now. My goal is for everyone to walk out of here having like a general idea of what the observability landscape looks like, no matter where you are in it. And so yeah, let's get started. So where do we start with? Sorry, let's go this way. Our agenda. So like I said, a little bit of history. I'm going to talk a little bit about metrics and traces, which is kind of more the newer observability stuff. We're going to talk quickly about distributed tracing and end on OpenTelemetry, which is the newest, best thing in observability. I think the history is important, because, especially in this situation, because the history over the decades actually mirrors a lot what you end up seeing in projects. You start with something simple and then you start building up to something more complicated. And if we just look at, if someone just throws at you the more complicated thing without understanding like where it comes from or why you'd want that, it can be a little bit overwhelming. So yeah, history. Let's start with print. Print is the king. Print has been around forever. I still use print. I'm sure everyone still uses print, all the time. It just works, and it's simple, and it's always there, and it gets the job done for a lot of situations. Print has a lot of different forms, and in particular, like ways to format the strings. You have the like the sprintf style formatting, which is has also been around forever. It comes from C. It's a little bit kind of gross. You have the dot format style formatting, which now you start getting a little bit nicer. You can like name your things. There's like, you can use format specifiers easier. And there's f-strings, which is kind of the newest thing that you'd use. So even within print, there's like evolutions. And I pretty much always use the f-string style format nowadays. But yeah, it's the brief history of print. It is the king. And then you have logging. The standard library logging. It's been available also not forever, but since Python 2.3, so quite a while. It can be a little bit gross. There's parts of it that are like designed around how it works in Java. So there's like camel case names that already is like a turnoff for a lot of people. It's quite complex to actually get working. Like I remember struggling to get it working to start with, which is not the usual experience with Python. But there's all this kind of stuff going on, right? You have like the loggers, the formatters, the handlers, like all this kind of stuff. This diagram's showing a little bit how that flow goes. Usually you'd call like logger.warning, logger.info. There's a lot of this that is related to early termination, because logging can be expensive. So if you're, for example, emitting debug logs, you don't want to do a bunch of work only to decide to drop those on the floor. So there's a lot of work that goes into just like, if your level's less than warning, then immediately drop it. If a filter says to drop it, then drop it. And only if it passes all of these checks does it actually end up getting emitted. So yeah, the flow is kind of logger.info, logger.warning. Then you can have filters on the logger itself. If those all pass, then it goes to the handler, which can also have its own filters. Then it goes to a formatter. Now it's a string, and then it gets emitted somewhere. A couple of interesting things is that this is all built around like, it ends up being a string. That's the idea. It's going to end up being a string somewhere, which, as we'll see later, isn't really what you want nowadays. You don't really want string. You're not just like putting something on a terminal and it ends up in a text file somewhere, and that's like all you can do. There's also this whole other part that's not even here about like logging hierarchies. If your logger has a dot name in it, then it starts interacting with imports kind of in a weird way, and that's also probably not really what you want to do nowadays. This is what it looks like to set up standard library logging. This kind of simplest form possible. I have a formatter that's using kind of these sprintf style strings. Slightly different, but the point is I'm going to put like a time in there, the level names like info, error, warning, and my message. I'm using a stream handler, which means it's just going to go out to like the console, pretty much the same as if it were print. You can do all kinds of other stuff. You can write your own handler. It can send things over HTTP. It can write them to a file. Those are, I think, the two most common ones would be you send it somewhere remote or you write it to a file. Then you have to make sure you configure the root logger, which you refer to with an empty string. Totally makes sense. Make sure you give it a level. I forget to do this all the time. Otherwise, you'll configure the whole thing, and there's no level, and then the default's warning, I think. So when you try logging.info, it's just not going to come out, and you're confused as to why. And then finally, you'd call a function like this, and then run the rest of your code is basically the idea. This is what it would look like then to like use standard library logging. So that would be like in your main function, in your entry point, where you set up your application, something like that. And then this is like if, in one of your modules in your application where you're just trying to emit some information. That part's a bit easier. It's slightly confusing with a dunder name thing. I'd say just don't think about it. Just always use dunder name. That's going to be the name of the module. Make that the name of the logger and call it a day. You can get a little bit fancier, especially if you're like a library and like, this is inside a private module and you don't want your logger to be called some weird private module thing. Then you can like just pass in a string that's like dot formatted the name of, like some conceptual namespace of what you're trying to make it. So it could be like, if you're an HTTP library, it could be like HTTP dot, send or HTTP dot receive or something like that. But yeah, configure a name, make a logger instance, which can be a little bit confusing. Why need to make a logger instance? It's just to give it a name. That's all. And then you can use that logger instance to emit logs. So there's pros to standard library logging, and the biggest one really is that it's built in. It's there. It's part of the language. You don't have to add any dependencies. It's always available since Python 2.3, so any version of Python that you want right now. It's worked the same for a while. It's super reliable. The cons are that, as you saw, there's complex APIs. There's all these like loggers, formatters, handlers, like all this kind of stuff, filters, all this kind of stuff. There's lots of choices. You saw the configuration. You have to configure everything. You have to choose like what type of format string you're going to use up front. There's no structure because, like we said, it always ends up as strings. You can kind of hack this a little bit. You can build formatters that take your data and JSON dump it, and so now you're emitting a JSON string. So you're kind of like serializing it still to a string, but it's now parsable in some easier way. But also they have no context. Logs have no context. Aside from like the name that we set, like the module name, you don't know where they came from. You don't know if you see a bunch of logs, pretty much that one happened after the other one for the most part. But you don't really have much more information on like what called what. Is this the same request that's being processed or two concurrent requests? or anything like that. So enter tracing metrics. These are relatively newer things that have shown up in, at big companies over a decade, but realistically for most of us developers, like the last decade. Context matters. Like we just said, logs have no context. And one of the really big things that traces bring to the table is context. So you've all probably seen like a stack trace from having some sort of error, like the thing on the left, right? I have some function called foo, which calls a function called bar, which calls a function called baz, which then divides by 0 and has an error. But I can see what called what. And that's really, really valuable information for debugging that logs don't have, but traces do have. So you can think of traces as kind of logs with context. So if I have, this kind of pseudocode here where I'm emitting what I'm calling spans, that's the nomenclature for like a unit, a block of code or execution in tracing. So I'll make a span within foo called doing work emoji, and then call baz. And then within baz, I'll start another span and then do my divide by 0. So if I run this and I get that error, and that's in my logs, I'll have not just the final stack trace from the error, but also each one of these will know which called which, so I can see the whole sequence of calling. Duration also matters. Logs don't really have a duration. Like logs have a timestamp, and you can kind of measure the duration of your code and then put that into your log, as kind of text somewhere. But they don't really natively have an idea of duration. Tracing and spans do. So every span, you'll see they're context managers. It's essentially measuring how long the code within it takes to execute. So if I have this doing work span and then I sleep for a second, and then I call baz and then I sleep for 2 seconds, I'll be able to tell from my traces that it's not that baz took 3 seconds, because I have another span around baz. I can tell that baz took no time at all. So I'll know that there's something slow going on within foo. And then I can go look at my source code and see if there's a couple sleeps in there. So I want to be practical here. I think it can be confusing to see all these different things, and I want to give you some practical advice on like when you should use tracing versus logging versus blah, blah. Pretty much I'd say use tracing. It's going to be the bread and butter of your observability. Whenever you can, put tracing information in there. It carries a lot of information. It's really useful in a lot of different contexts, debugging errors, debugging performance, and there's a few cases where you'd still want to use logs, like things that just don't have a duration, or it doesn't really make sense to have a duration. You can still use logs, but for the most part, you're going to be using tracing. Now let's talk about metrics. Metrics are something that kind of showed up before tracing, but I think a lot of people still don't use. They're this kind of thing that big companies would use, and you have to have like huge teams to manage them. Nowadays it's a lot easier. But really where the power of metrics comes in is in summarizing large amounts of data. So say you have a service that's doing a lot of requests, right? And you start putting these trace things in there for each HTTP request. All of a sudden you're emitting, a duration, essentially like some lineage information of who called who, and all that kind of, maybe some structured attributes that you're putting in there, like some headers, the username, like for every single HTTP request. That can get expensive. So you can use, stuff like sampling, which we'll talk about later. But really, you probably still want to measure the latency of your server, so you can start emitting metrics for that kind of thing. And that means you're just measuring for each request, like how long it takes as a number. And importantly, you can aggregate that really performantly. So your application will do statistics on that and emit distribution of latencies before it even sends it over the wire. That's very compact to send. That distribution of latencies can then go to a collector or to some sink, which then takes that and reaggregates it for all of the instances of your service, if you have multiple, deployments on multiple, EC2 instances or Kubernetes or whatever you have, you can reaggregate that. So, and then what you get is, that aggregated number that's super cheap to store, super cheap to do operations on, and you can make, these sort of pretty charts out of without costing you an arm and a leg, both in terms of amount of data you're sending over the wire, amount of data you're storing. So when should you use metrics? Metrics are great when you're trying to get accurate summary information that you don't really want to sample, but you also don't need, the full traces for. And finally, when should you use logging? I think logging is mostly superseded by tracing. There's not that many scenarios you'd want to use logging. Like I said, there's, if you have something that doesn't have a natural duration, but really a lot of it is integration with existing code bases. You might have a code base with a lot of logging and you want to integrate that into your tracing, you can do that. You might have third-party libraries that aren't really instrumented for tracing and are only instrumented for logging. You'll probably also want to use logging there. Quickly, distributed tracing. This is kind of one of those jargony words you hear thrown around. It's really not that special. It's just the idea that you can, from one service to another, pass information or pass really who called who information. It really is just a header with some, like a made up ID. The calling service makes up the ID. The receiving service receives that ID, sets, and then every time it emits telemetry, it says, oh, this is the ID that called me. It doesn't have any more information, but then when you put it all together in an observability platform, it can tie those IDs together. So let's talk about OpenTelemetry. OpenTelemetry is the shiny new thing. It's the future. It's what you're probably going to be using for observability. It brings together a lot of existing standards. They're called like OpenCensus and some other stuff. Doesn't really matter, but it has spans, tracing, metrics, and logging. And what it really is it's a spec so that everyone can agree on what to call these things, on the structure of the data, that sort of thing. And then practically it's SDKs and implementations for many different languages, web frameworks, database drivers, all these sorts of things. It's a CNCF project. It's open source. It's maintained by a lot of big companies, including telemetry like observability platforms, Datadog. All these kinds of people contribute to it. It's a really cool project. But OpenTelemetry is not simple. You still have to choose a lot of things. You have we traded the logging formatter, street handler, all that stuff. We traded it for text map propagator, a processor, an exporter. Do I use a gRPC exporter, HTTP, a tracer, which you have to generate with a tracer provider? There's the API PyPy package. There's the SDK PyPy package. And then you try the docs, and because it's a relatively new project that's in flux and it's complex, the docs didn't work. You may have found some old ones, or they're outdated, who knows. This is what it looks like to set up OpenTelemetry. Like I said, you have to choose a processor. In this case, I'm choosing the console process. I'm choosing the batch span processor, which does batching and exports things in a background thread, along with the console exporter, which again is kind of like just printing it to the console. I'm going to make a tracer provider. I'm going to set that as the global tracer provider with a trace module. Then I'm going to get my tracer from the trace module, giving it a name. Again, this could be Dunder name, but you can also give it a meaningful name. And then finally, I can start emitting spans. I'll also point out that you can attach structured data to these spans because unlike logs, they don't just end up as strings. They get sent structured over the wire. So you can, add a dictionary of data, a list of stuff, whatever you want to add there. But now let's talk a little bit of costs, right? You started adding all these traces, you did all this magic at instrumentation, but now you started sending it somewhere and you got a bill for $1 million. That's not good. So my quick recommendations on costs, just so you don't get blown out of the water when you first start trying this stuff. Metrics are great. Sampling is important. Sampling means, you only keep 1% of the data. If you have really high volume, that's perfectly fine. You'll still get meaningful information out of that. There's two types of sampling. There's head sampling, which means you decide what data you throw away before you start emitting it. That's just using like a random number. and tail sampling, which can be fancier. You can say like, I only want to keep exceptions, or I want to keep this or that, but also is more complicated to set up. Then you have retention. This would be a feature that wherever you're sending the data provides. So you can say, I only want to keep data for 2 weeks or for 5 days. That's enough to debug incidents. And after that, throw it away to reduce costs. And then I also say, think about sending data out of band. This is something you'll have to do. Like if you want to like save information about a pandas data frame or something, maybe save the data to S3 and just include the key in your logs. Don't just like try and dump that to a dict and then put it in your logs. You could, but you're going to pay quite a bit more for that. So what does this all end up looking like in the end? Well, the thing about OpenTelemetry is you still have to send the data somewhere. And it's an open source, free project developed by a lot of people. But you're probably going to end up sending that data to an observability platform. That could be, there's a ton of them. That could be, Datadog, Relic. Like, I forget which ones support OpenTelemetry now and which ones don't, but if they don't, they will. So pick your observability platform. You can send them OpenTelemetry data. And the idea is that you're going to end up getting something like this, where you can, search through your data. You can see how long things take. You can debug errors, like, all that kind of stuff. Different platforms offer different things. And this is where I'll say I work for Pydantic. We're both an open source project, but we're also building an observability platform that's called Logfire. There's a screenshot of Logfire. And we're presenting more on what Logfire is in particular and the features of our observability platform that we think will really, really resonate with all of you at 12:35 in Lasagna. Thank you.
Thank you very much. I will see there are some questions on Slido, but
Can we do one or?
Sorry?
Can we do one or two or?
Yeah, sure. We have plenty of time.
Okay.
But yeah, no one has used it.
No
question
questions
in the room.
Okay.
No, wait. Thank you.
Is it faster or is it slower than logging? Do you have a computational overhead?
I'd say I'd expect more overhead from using like OpenTelemetry than from using logging. I think there's just more going on. It's not like, I wouldn't say it's like inherently greater. Having looked at the source code, I think there's more source code.
We have one from Danecom. Does adding OpenTelemetry add latency or use extra resource for logging purposes?
Yeah, it's a great question. So most of the time when you set it up, you'd use like that batch span processor I showed. And what that means is there's like a background thread running that's creating batches of your data. So it'll only send out data once it's accumulated a certain amount or every 5 seconds or something like that. So when you actually emit a span, there's not going to be much overhead associated with that, but there will be HTTP requests going on in the background to send the data. Now, that doesn't mean there's no overhead. So if you're like trying to sort a list and you give it, like the key function is a function that's also emitting spans, and you pass it a 1,000,000 element list, that's going to get considerably slower. But if you're making a database request that takes 50 milliseconds or 10 milliseconds, adding less than a millisecond of latency on the compute that's taken to create this span object and pass it to the background thread and that kind of stuff, you're probably never going to notice that.
Okay. What's a good starting point to get an entry to OpenTelemetry? Which platform would you use to have a low complexity entry?
Logfire.
Based. And then we have, is it worth to set OpenTelemetry for endpoints that are used infrequently and do expensive computation?
Yeah, I mean, I think, well, it's really up to you and your application, what's important or what's not. It's like, is it important if that endpoint, fails or gets slower? Do you really care? I mean, sampling is a really important thing. Unfortunately, there's no good story right now for sampling like an endpoint differently than another. Like, say, hey, I want 100% of the data from this endpoint, 50% of the data from this one, and 0.1% of the data from this one. There's no good story for that in OpenTelemetry. I think there will be in the next couple of years, but right now you kind of have to choose like a number for your entire application.
How much overhead is caused by using the auto instrumentation with hotel compared to manual instrumentation in your experience?
There's really no overhead. I mean, the way the auto instrumentation goes is it just adds hooks to the things it's instrumenting. Sometimes, unfortunately, via monkey patching, I think that will improve in the future. But really, it's just essentially editing the code and adding the spans that you would be adding anyways. So there's no more overhead to that versus manual instrumentation. Now, if you go and you auto instrument everything in your code base, now you're just emitting more spans in general. But that's not more overhead than if you went and like, edited those packages or whatever to add those spans.
I will fix it later. Sorry. Curious! Exclamation mark. So, does Span use Context Manager internally?
I mean, most implementations of tracing use context managers as to like in Python at least to like represent what a span is. In other languages, it might create an object that then gets dropped, and when it gets dropped, that's when it ends. But in Python, we use context managers, and it's really just like the right primitive to capture something that encapsulates a unit of work, has a starts and ends, and has a duration. I mean, yeah, it uses context it probably opens other context managers internally. I'm not sure if that was a question.
Yeah, I mean, it's not really my job, but I think it was cool. Any advice on how to structure your traces so to simplify debugging when something goes wrong?
I mean, I think, it's really, there's no secret. It's just like with logging, you need to like think a little bit up front about where you need, to put traces, where is there likely to be errors, where is there likely to be slowness, what parts of your code are interesting and important. So, I mean, like an obvious one is like a database query, right? Like you have an endpoint, you want to know how long it took to process the entire request, and you want to know how long it took to do the database query. That way, when it's slow, you know which one it is. If you see the database query slow, you're like, maybe I need to add an index. If you see the whole thing is slow, you're like, am I like running expensive sync function in my async, endpoint or something like that? So really, it's just up to you to know what information to include and where to put the telemetry.
I think this one is worth it to check it together because is there a strategy for open telemetry, I think, if you're on premise with no cloud access?
Yeah. I mean, so the nice thing about OpenTelemetry is it's an open standard, and there's actually several open source projects that you can self-host. Logfire, we can talk about it at the other presentation, is not an open source project. Like part of it is the part that you'd run, but like we don't give it to you for free is the point. We're trying to make a commercial company. We want to make money, and we want to support Pynantic's development. But there are other projects out there that are completely free, open source observability, platforms in a repo or whatever we want to call them that you can, clone, edit, or just host yourself, and you can send your OpenTelemetry data there. If you're there's also other companies that already offer on-premise solutions. We plan on doing this at some point. We don't currently, where you can host their observability platform with like a license or something.
Okay. You still have a question? That's the question. Okay, thank you very much. Okay, we have 2 minutes left, so if you want to, okay.
Completely new question here. So if I want to start from scratch on the topic, I can start even if it's not free with Logfire. So it takes my hand from the beginning to having something completely working without having to learn million pieces to combine together. There is some glue between all the pieces, or it's just a part of something that solves part of the problem, but there are another 1,000 million tools to learn and so on.
Yeah, I mean, that's the idea of Logfire, right? It's that, there's OpenTelemetry, like we saw, you can set it up. It's just a little bit complicated. You have to learn all these primitives. We just choose, what we think are sane defaults, so that you don't have to configure as many things. You can still go and configure them once, maybe you're like more advanced and you're doing more stuff and you need more customization. It is that you can still do that. But we're trying to make it so it's just simpler to get started, and you don't have to learn what the tracer provider is and all that kind of stuff. You can just start emitting some stuff.
Okay, last question, I think. We have just 1 minute. Is logging going to die soon? What's your opinion?
Yes and no. I mean, I don't think this. I mean, the standard library logging module in Python is going to be there, forever. They're not going to remove it. So I don't think logging is going to die in that sense. I think, when people set up a new application, they're going to be using Logfire or, some other the OpenTelemetry SDK directly. I think a lot less people are going to be relying on standard library logging and, parsing string logs as their primary source of observability. I do also think there's a chance that, at some point Python adds some sort of tracing in the language itself, and then new libraries won't be using standard library logging. But I mean, logging's been around for so long and it's so ubiquitous that it's going to stay around for a while.
Okay, the time at our disposal is finished. So thank you very much for attending, and thank you for your talk. Now we will have a talk by Peter. It's called Pythonic Deployment of Python Applications. If you do Kubernetes, your deployment is a lot of YAML code, isn't it? And of course, you can't unit test it. It's all YAML. What if you could do everything in Python? What if you could associate workloads using Python code? Here you learn about Juju and Charmed operators. You love it. Peter is a developer of people, companies, and code. A perfectionist with deadlines, just like Django. A seasoned maintainer and contributor to open source projects, usually related to making software development easier and more fun. Welcome him. Thank you.
Thank you. Grazie, Luca. Yes, I'm happy. I'm happy to have you. Thanks for having me. Pythonic deployments of Python applications. But before we dive into that, let me first tell you what I came here for last week. Really, I came here for to heal from the damage I suffered at work. I work in Europe's second richest country, and I suffer every day. I recover in my spare time. So that's what I do. I work and I recover. I work and I recover. I don't live. And whenever I can afford, I spend time in Italy. Yes, in Italy. And to heal from that damage that I suffer from work, to spend time with the warm-hearted people in the sun, to feel the passion that the people have here, and to make friends. So what's wrong with Europe's second richest country? There are things that money can't buy. Friendship, open-mindedness, passion to work on great results together. Willingness to collaborate, pair programming, taking the blame for failure as a team, holding hands in stormy weather. Yeah, maybe it's also the attention that we heard in the keynote this morning. So money can buy an agile mindset, in essence, and that makes me sick. So what did you come here for? So if you're not Italians, that's probably what it is. It's monuments. And if this is your first time in Italy, that's all right. But if you return, you should really come here for the country and for the people, for the passion for everything, for the attention that those people have, per la voglia di far festa. And there's a lot to learn from this country, and there's a lot that Italians do right. And some of the things we just need to understand better. And for example, why Italians try not to pay taxes. Did you know that the value-added tax in Italy is 22%? That is insane. And you know what Italians do about it? They don't pay it whenever they can, because it's unfair. And on the flip side of the coin, do you know why the tax is so high? Because when only a third of the people pays the taxes, taxes must be 3 times as high. Logical, right? And there's more that doesn't seem logical at first sight. So take these words on the slide here, for example. So on that side, you see the female gender words. They all end with A, you know, pizza, vita, famiglia, ragazza, bella donna, and in the plural with E. And then on the other side, we have the male gender words. They end all with O and with I in the plural, you know, ragazzo, uomo, libro. But then it starts getting complicated. We have these E, you know, E, wasn't the plural here with the E? Yeah, you have padre, mese, mare, fiore, etc. Okay, fine, this probably comes from Latin. But then it even gets more complicated. You have la mano, the hand, and in plural it's le mani. Oh, okay, so we have the article from the left side, and we have the suffix from the right side. And the same for the plural. Okay, well, at least it's consistent. But then, even worse, we have the deck chair. You know the deck chair, it's important. It's la sdraio and le sdraio, the plural. So what's happening here? So this is so complicated that even Italians don't get it right. You know, in some regions of Italy, they say la sdraia e le sdraie, vero? Tipo Roma. My wife is from Rome. And my wife learned in Tuscany that it's actually la sdraio, le sdraio. Perché? Why? Because there's a reason for it. For real, it's la sedia a sdraio, the chair where I can lay down, and le sedie a sdraio, the chairs where I can lay down. Okay. This was your personal dose of Italian for today. I hope you enjoyed it. My name is Peter Bittner. I'm a developer of people, companies, and code. You'll find me on Mastodon. I've almost left Twitter. And I'm also on GitLab and GitHub, a little bit on Bitbucket still. And I'm an open source developer and a Linux person. I'm a maintainer of and co-maintainer of various open source projects. And I'm your host for learning about Juju and charmed operators here at PyCon 24. One important disclaimer before we get into things. While I use the logos and the colors of Canonical and Ubuntu, I'm in no way affiliated to Canonical. Okay? I'm in fact, I used to be a fanboy of Ubuntu, just like iPhone and MacBook users are Apple fanboys, but even that preference is not as strong anymore as it used to be. And also, maybe some of my views are actually wrong, as I'm neither a Juju nor an active charms developer, so take my explanations with a grain of salt. All right, let's step back a bit and look at how applications are deployed, so how you maybe deploy them or have deployed them in the past. So what are our options when we deploy applications? So the simplest thing, the straightforward approach is a scripted setup. So with Python, we would create a virtual environment, we would copy source code to the host. Maybe you use Git, so you initialize, you clone a repo on the host, you pull it when you deploy, and maybe there is some bash involved, or 10 years ago, there was Fabric, I think, in Python, or you do Ansible nowadays, which is not much more than just bash and SSH, or some other configuration management tool, right? If you want to get a little bit more advanced, a little bit more structured, then you create a Python package. That is something that you can pip install, your own software. That's a little bit more clean. You can also uninstall it almost cleanly. The dependencies stay there, but it's a clean approach. Yeah, yeah. Oh, then we have got the system package. System packages. This is when you have more than just your Python source code. You have maybe configuration files that go with your application, and you target a specific operating system. You have a package manager that takes care of deployment, so you get some support that you don't have when you do things on your own. Then we get closer to what we do when we work in cloud-native environments. We run containers. That allows us to copy and install software in a container image. So we prepare things up front. We work with a Docker file. Maybe we work with Docker Compose, either for development or even if we want to orchestrate a simple setup on a VM or something. You have clean isolation. That is an important thing of it. Okay. I should have changed the batteries. Okay, So, and then we have Kubernetes. You maybe use Helm when you use Kubernetes, or customize depending on your preference. You write a lot of YAML code. You use something like kubectl apply in your pipeline if you do the push-based approach, or you use GitOps, which is the pull-based variant, etc. Right. So Kubernetes you use to make things work together, and that's what you describe in the YAML file, right? In YAML files. And then there is more, though, that needs to be done. You know, you need to take care of backups. You know, maybe you don't think about it first, but sooner or later you figure out it would be good to have backups because, you know, you never know if something goes wrong. And then remember, a backup is only worth as much as you can restore it. So if you never try to restore it, don't even back up. You want to know if something goes wrong. You want to know maybe upfront when there is a tendency that something goes wrong, whether your application maybe gets closer to an OOM, out of memory error. You want to do error tracking and tracing. You want your software to be integrated with other software. Probably you have to do this manually. You have to do this in YAML or something. You want to do upgrades, and then the impossible. You want to migrate to new hosting, you know, because everybody goes to Microsoft Azure. Yeah, move there. Okay, we start from scratch. Then you figure out, oh shit, oh, sorry, it has become too expensive. So how we move away? Yeah, that will be a project of probably a year or half a year, minimum. So, okay, so let's look at what the before mentioned approaches actually do. They solve different problems. The scripted setup, with that one, you try to bring up the same setup as locally develop. That's what you do. With the Python package, you install the application the Python way. You can do pip install, it's more structured. It's cleaner to read and deployment configuration. And pip takes care of where the source files are placed, so there are side packages, and it installs launcher scripts. You can even package some data files if you need. With a system package, you combine the binaries and config files, data files, and you follow the conventions of a distribution of your OS. Yeah, and with a container setup, you satisfy it's possible that you free yourself from resolving the dependencies over and over again when you have a new client, a new target environment, because you satisfy those dependencies independently from the target environment, and you're all set when you have a new target environment to face. Great, and with Kubernetes, what you actually do is you declaratively define how containers should work together. You do not make things imperatively. You only say what is the what. So what do I want to have, and the how is being taken care of by the Kubernetes engine. So the Kubernetes engine takes care of how you scale your applications, how you start it up, if something goes wrong, if it goes OOM, if it's restarted, and so on, or if a node goes down, that it's being transferred to another node so that there is no outage, etc. You don't do this yourself. You should only say what you want. Kubernetes takes care of the rest. And that also means self-healing environments. So that's the idea of Kubernetes. You define how the system should react, what is the state you want it to be in at all times, and if something goes wrong, if an interruption happens, Kubernetes takes care of the rest. That also means you should not interfere or correct the state manually. So don't do kubectl something and mess with the cluster, even though everybody does it, right? But you shouldn't. So automatic operations should do the job. That's the actual idea. Great. Battery outage again. So, but then there are more things. You know, there's things like these day 2 operations that are not covered by any of those solutions here. So this is the monitoring, logging, alerting, updates, configuration changes, backup, restore. Yeah. So wouldn't it be great if we could have that solved by technology instead of doing it all manually ourselves? That's where Juju comes in and all its related tooling. Okay. So the idea of Juju, that's actually a West African word, so like everything from canonical. You know, Ubuntu is, what is it, humanity to others. And Juju is the magic that deals with good luck. And the charm is a spell, you know, so it's like Juju does some magic. So that's practically the mission or so. So the idea of Juju is that in addition to deploying your app using containers or not, you also cover and have entire control over day 2 operations. Also, your application setup should be self-contained, so you shouldn't have to mess from outside. Your application should be able to, for example, grab the secrets for accessing the database from the database itself, where it's generated. And it should be able to connect to other components. And all that's kind of magic things like auto-provisioning, configuration, secrets, or something like that. Canonical tries to provide a uniform tooling for all those aspects of the concept. And also to solve various related problems. Juju is the orchestration engine. It manages the application operation on any infrastructure. It uses charms. A charm is a software operator. So a software operator is a piece of software. Here is written in Python code, and it automates all aspects of the application's life. Then the lower 2 parts, rocks and snaps. Maybe you've certainly, if you use Ubuntu, you've certainly heard about snaps. They are like a bit hated. But rocks are, you know, it's like Docker, OCI images, standard. They're trying to make Docker images safer. That's what it is. But all those 3 tools, by the way, this you see is written in Go. These are written in Python. These are CLI tools then. Charmcraft, Rockcraft, and Snaps. Sorry. And Canonical tries to provide uniform tooling for that. That's basically it. Good. So currently with Juju, there's still this distinction between machine charms and Kubernetes charms. And machine charms are basically charms for bare metal and VM and system container, so you can deploy an application to something else than Kubernetes. And Kubernetes charms, for Kubernetes charms, the target environment is Kubernetes. Maybe I forgot to mention that what is actually interesting about Juju. So what Juju does, what Canonical tries to do with Juju, is they actually try. Let me just go back if that was there. No, that's fine. Probably it's still to come. So what they try to provide is that we saw this in the first slide here. So what Canonical's approach is actually interesting. That's an important to note. I forgot it. I'm sorry. So what they try is to provide a total abstraction across all different workload environments. So they've even a general term for a cloud, a VM, bare metal. They talk about a substrate. So you deploy to a substrate, and it can be anything. You know, you're not doing something for Kubernetes, you're not doing something for Azure or so, you're doing something to deploy something wherever you want to go. That's their idea. And maybe maybe you don't know, and I don't know if you've noticed, but in the last 5 to 10 years, Canonical has built an impressive cloud infrastructure tooling portfolio that goes way beyond just Ubuntu and the discontinued Ubuntu phone and Ubuntu TV. And interestingly, they have learned a lot from the Ubuntu phone than over IoT, because when you remove the GUI, then you have all the IoT tooling, and that's where also snaps come from, and then in the end ROCs and so. And most importantly, Canonical tries to elegantly simplify operations and infrastructure from IoT to VMs, private and public clouds. They also address one of the main concerns of virtualization and Kubernetes, and what could that be? That you have this infrastructure overhead by too much abstraction. You know, you can do everything in Kubernetes, but then it gets slow and complicated. So with Metal as a service, you can turn your own physical service into a cloud, and you can leverage the speed of bare metal. So this is that logo here. And this is simply done by data center automation. And this is all super elegant, and I think we can attribute this to Mark Shuttleworth. And because if you know Ubuntu a little bit, you've always seen Ubuntu is simpler to install than any other distro, and it has it has a super unprecedented startup speed like no other distro. Yeah. So that's my personal compliment to Mark Shuttleworth. So let's come back here. So you can see there's still a difference between Kubernetes deployments and machine charms here, but you can see there are similarities, and Canonical is actually working on uniforming these things. And so you have the controller here, Juju controller. You have a client here, Juju client. So these are these CLI commands that you can think of that you would send requests to the controller, and then that makes the agents here do their work, basically. Pebble is a replacement in the cloud world for systemd, and so they try to uniform everything. Good. So let's go through those parts. There's some new vocabulary to learn. Thank you. But once you actually buy into the idea of generalization, you fall in love quickly with those names. You've got, don't read this to you. You've got the documentation here. It's all well documented by Daniele Brocida, by the way. So he's the wizard behind all the well-structured documentation. Charms are these Python logic that drives the operators. You've got this CLI tool, Charmcraft, that does init, pack, login, upload. And you can see from these comments here that there's something more behind it than just preparing a software solution. And the main objective of Canonical is actually, and that's what those comments are hinting at, to build an open source library of curated charms. You know, so you have all those charms that you can install. And remember that Canonical is, in the end, an infrastructure company. So what do we do there as application developers? But nothing is stopping us to use Juju also for, and charms also for custom applications. And actually, there is some work in progress at Canonical for that, for Flask, Django, and so on. Great. Rocks. Oh, great, thank you. So Rocks is just something else, an alternative to Docker. They try to make things more uniform and safe, because, you know, the Docker world is a bit, you know, everybody does like they want. The main problem is you do have the root user running inside the container and so on. And you've Rockcraft as a CLI that just behaves like you can operate like Charmcraft and so on. So it's more a declarative approach there instead of with a Docker file where you have this imperative approach where you say what to install and so on. And similarly to snaps. So with snaps, what they try to do is to have self-contained applications that are easy to update. You have no dependency issues. You have a simpler deployment. That actually comes originally from IoT, where you have the urge to have things automated because you're not always on the screen, because an IoT is there in the corner, and so there should be some way of automatically updating things. Great. So, okay, let's jump into a quick demo. I'll try to show you a few things, just a few nice little things. Let me just change my screen settings so it's easier for me to work. Okay, so you can see that, right? Okay. Great. So, okay. I prepared some directory, PyCon. Oops. Yeah, okay. Great. Let's start from, what do we have? Charmcraft. Okay. So, cd. Actually, let's start from the bottom. We have these snaps, because that's faster. So we have nothing here. I have this Snapcraft just to show you that we have all this uniform tooling. It says, did it do something? No. We say Snapcraft init. So basically what you would do, you would have your application, and in a repository, and inside the repository you would run Snapcraft init. And then if you are a Debian developer, or if you have seen in other repositories this Debian folder, so the snaps folder is similar to that. So in your repository, the init command would create the snap repository. If you go in there and you run a Snapcraft, pack, then this would start and try to create something. We'll see what it does. In the meantime, now it's already done. Yeah. So what did it do? Oh, it's still working. Sorry. Yeah, it does some dependency building. So basically what it does, it will create something like I would compare it to a Docker image with some layers, because it actually creates a file system. We'll see that later. So in the meantime, while we wait, we do the same thing with PyCon. Whoops. We do the same thing with rocks. So I do a rockcraft init, okay? And then let's just try to see what we have here. So we have created a rockcraft YAML file. Maybe you see this better like this. And if I open this like this, you'll see, yes, I trust. This, how does it look like? What does it look like? It's a YAML file, so it's more a declarative approach. Here in the parts, you would define some dependencies, plugins, and so the base would be Ubuntu. This is like the base image you define in Docker, similar. So actually, what I think it's here, you can, Canonical has curated Docker images that it uses as base images for that, and the plugins you can, I think, you would list with list plugins or something. Yeah, it's like, I think it's like that, list plugins, and yeah, not like that. So you get the idea. Something similar. Okay, but most importantly, we do a pack here. So because we do the same thing as with snaps, and this will create something else, not a file system, but it will create, when it's done, it takes a while, yeah, this will create basically a zip file. The same thing will happen, and by the way, also for the charm. So yeah, it takes longer than I hoped, because at home internet connection, but yeah, I don't know. I've got fast web at home. It's a bit slow. I don't know why. It calls fast. Yeah. So anyway, let's try to do another. Open another here one as like Scratch, PyCon, through. So where do you want to go? We create a machine charm, okay? We make a, what is it? Charm craft in it. So what it did, it created an entire file directory structure, and most importantly, you get this. Oh, that's the wrong. Sorry, that would be for later. Interesting, why that comes here. Oh, that's true. That's totally fine. Yeah, so you get kind of requirements. That's the ops framework that I mentioned earlier. You've got things, test configuration prepared here. You've got tests prepared. You've got the charm prepared for the integration tests, and you have the actual charm here. So it's a class that inherits from charm base, and it has some a few functions. So it is imperative code with a few declarative points in it. So like you have the configuration here that you can. The idea of this is an end user should be able to change this easily with a config command. You would just say if the startup is enabled or not, or something similar, or change the environment variables with a command. So and also if you're here, obviously with Charmcraft you could do the pack again. This should go faster, I hope. Let's see where we are. Look, okay, great. With the snaps, we're done. So we have this snap here. If you look at what the snap is, actually, we see that it's a squash.fs file system. If we mount the squash.fs file system, squash.fs mount. Oh, actually, it's like sudo. What did I do? Oh. Let me just check this again. Oh. Now I've got my nodes here. Minus t squared. It should actually work. Sudo mount. Oh. Oh, this quite. Yeah, that's right. So my notes were wrong. Like this? Yes. Yeah, great. Okay. So now here, thank you. So you've got basically this structure here. So there's a snap YAML file and directory, a GUI. There's nothing in there, obviously, because we have no application that we actually prepare, but the director structure is there. Great. Okay. So you get the idea. And then, the rocks are still busy, but that builds, in the end, a zip file, like the charm here. So it builds like, let me just have, what is the file? Did it run a pack? Charmcraft pack. launching environment. Okay, I'm done with that. Yeah. So basically, you get the idea. The last thing that I would show you. Can I still, or can I still go? Go ahead. Sure. Good. Oh, less than 5 minutes means I still have 5 minutes. Yeah. So basically, to show you more about the code here. So you know what? What I did wrong here is the Charmcraft init was actually wrong because that created a getting more. Actually, with the Charmcraft, as we still have machine charms and Kubernetes charms, we have to specify what we want, and we have this thing that is called profile. And if we want a machine charm, we have to say profile, and it's a machine, and then we get a different setup. And so that actually confused me, that's right. And if I do a Charmcraft pack, that should now go fast actually, then we get a, yes, come on. We get a charm file, there it is. And what is this charm file? You know, it's file, it's machine charm. It is a zip archive, so if I do machine charm, and you can see this contains the manifest files, you know, it just contains the source code. What it does, it packs a complete virtual environment. Why? So it makes it all self-contained. So this operator contains a virtual environment. So basically what it does, and this charm file is then being uploaded to CharmHub, and Juju would download it from CharmHub, and it would just run it using that virtual environment. And by default, it runs, it creates this virtual environment, you know, based on whatever Ubuntu version you run. And so the default Python here on 2204, for example. And in the source folder, you have this charm code, you know, for machine charm. This is very simple. On these onstarts, these are handlers that you actually, you know, initialize, and you say onstart here. So it's all actually, you know, self-explanatory. You can go and yeah, debug it, go after it, and try to understand it. And then, most interestingly, we have these hooks, and what these hooks do, for example, the start, is they just start the Python file. So, and what that hints at is that you don't have to use Python if you don't want to. Funny to say on a PyCon, but originally, the idea was you could use any technology, but Canonical obviously encourages developers to use Python, so there is uniform implementation for those curated charms. Yeah, so that's what is inside of charms. How would we do the Juju? So if we run Juju, I can show quickly how this is done. I have a more elaborated setup that I've prepared for this. It looks like this. So this is an actual Django application. You can see there are more. I have collapsed all those different functions because, for example, this Django application, it has an integration with a database we defined, you know, with Postgres in this case. So you code this there, and then you can, with the Juju command, you say, don't know really what the Juju, I think it's Juju integrate or so. Yeah, if this errors out. Yeah, but that's not, so this Juju integrate, and with that database relation, it would just connect to Postgres, and Postgres provides an endpoint that automatically, makes them talk. And the cool thing is you can say, Postgres, give me your password. So you don't have to maintain any secrets. You don't have to generate any secrets on the pipeline. It's all self-contained. So a charm knows what it does. And it's the Postgres charm that deals with the secret. I don't have to, deal with creating a user, creating a schema, anything. I just connect the two, and then I start Django, Python manage PyMigrate and all that stuff. Yeah. So yeah, I don't have time to show this anymore, how Juju starts up, but maybe I can just try to start micro Kubernetes here on my machine and try to start Juju up while we have questions. Is it fine? Do we still have questions?
I mean, you can choose. You have 4 minutes for questions, but you can use that.
Yeah, no, just let's go ahead, yeah.
Okay. Thank you.
Thank you.
The first one is kind of complicated for me, so if you want to read it for everybody.
Okay. Deutsch, was German? No, this one.
Yeah.
Ist Deutsch besser mit Articles? Oh, mit Artikeln. Der, die, das, Nominativ, Akkusativ. Ask my wife. She's Italian. She knows German better than I do. She has studied that stuff. Sorry.
And the second question, a little more serious, is what about Windows?
Windows are those things that you get when you make Windows smaller and bigger. Windows are those things. What are you talking about? No, seriously, Microsoft Windows?
Yeah, I think
So what is the question? So, I don't know if you, so a Juju is a Go application. So if you can have a Go binary, I think there is an exe file in the Juju repository, in the releases. So if you can run that on Windows, you can probably also run Juju on a Windows machine. And then you can, I think you can run you have also container images that run on Windows now,
Also the
right?
subsystem.
So .NET and something.
WSL also.
No, but that's a different story, yeah. But you can even run native Windows on.
Linux application on the Windows machine that is like a small virtual machine layer. It's not native.
Let me just. Thank you. Okay. I don't know about that, yeah, but maybe you're right. I mean, you're certainly right. I don't know. Next question.
That's it. I think if there.
Thanks a lot. Thanks for coming.
Thank you very much.
advent of code? Raise your hand. Nice, I'm as well, and it's kind of hell in December, but who played knows how to win. So we will have a panel of advent of code, but the room changed. So if you want to attend, please take care that the advent of code panel will be moved in tagliatelle. The pasta rooms are downstairs. And instead of focaccia, so instead of there will be there, and of course the talk there will be in focaccia. So just announcement, take care if you want to attend one of the other avant food in tagliatelle. Thank you. And now, how do you feel after lunch? How's your energy about? How's your hand? Up, up, up. Depends on what you ate. But right now we are being recharged by this wonderful talk. We have Serena Palazzo with us. She has an amazing background in physics. She works with experimental physics in Atlas, the CERN laboratory experiment. And above all, she's a senior data scientist and head of the data and AI department in Overture. And today is going to talk about generative AI in the creative environment. So a big applause for Serena, and the stage is yours.
Thanks. Okay, thanks for this introduction. And as you say, today I will talk about generative AI and how to use Python libraries to build and use generative AI models. But before to go to the talk, just a brief introduction about the company where I'm working right now. We are Symphony Prime Group, which is an holding of different companies that aim to develop digital transformation. And in particular, I work in Overture, that is the technological boutique that is going to deliver solution in cloud, and in particular in Google Cloud, because we are a Google Cloud partner. So going to the talk, I will give you an introduction about generative AI, so the theoretical concepts, and then I will move to generative AI models and the difference among the models that are nowadays used. And then I will talk about how to use Python to build and use these generative models. So about the introduction, generative AI is a particular branch of artificial intelligence, even if today we are going to talk almost always about only generative AI. Of course, there is a lot out of generative AI. But this part of artificial intelligence is used to generate original content. We can use generative AI for a lot of tasks, for example, in art, in music, design and fashion, literature. Okay. And since it is something that is going to grow very, very quickly, there will be a lot of application that nowadays we don't know and will come very soon. Of course, Python as a versatile programming language is the most used and the popular choice for building and use generative AI models. And we will see the main libraries that are used today in this particular field. So before to move to the Python part, there is a big difference between discriminative models and generative models. Discriminative models are basically the ones that we can see here in the picture on the left, which are basically the ones that are used to predict some labels. So for example, in the most simple case where we have to decide about spam and not spam email, we put a boundary decision, and this is something that is discriminative. And then we have generative, where basically we do exactly the contrary. So we aim to predict the feature and not the label, as we can see on the right. And these kind of models, as I said, can be used in several domains, and today, as we can see in the talk, we talk a lot about large language models that are used basically in all the text domains. So moving to some details about the difference among the generative AI models. First of all, I want to introduce the Python libraries that we will see in the talk and that are the most famous used today for this kind of AI branch. So we have, of course, TensorFlow and PyTorch that are one of the most famous artificial intelligence frameworks, and these kind of frameworks also in generative AI are used, and are used in particular to build GANs, BAA, and transformers. And then we have Hugging Face, that is this popular open source framework that is used in particular for tasks that involve transformers models. And then we have LangChain, that is something that orchestrates the solution, as we can see later, and are in particular used for large language models. So as I said before, generative AI is not just large language models, even if today, basically, we listen about large language models everywhere. There are a lot more outside, and there are the most common generative AI models that are used and built in generative AI are GANs, that are generative adversarial networks and are particularly suitable for images. Then there are variational autoencoders that are particularly suitable for anomaly detection. And then there are transformers, so large language models that are particularly used for everything that is regarding text manipulation. Starting from variational autoencoders, these kind of models describe an observation in a probabilistic way. So basically, we are not going to have an exact result starting from the input data, but we are going to have something that in a probabilistic way is very similar to the input. So for example, here in the image, we can see that starting from the image on the left, we can have something that is very similar, but is different because the generated image has glasses. And these kind of models that are used for anomaly detection, but also for image generation, are built by two different architectures, a decoder and an encoder, as we can see later. So the architecture of the model itself is very complex because it's not just a single architecture, but it's made up of two of them. In a similar way, generative adversarial networks that are made up of a generator and a discriminator. So also in this case, we have two architectures and not one. And generative adversarial networks that were introduced for the first time in 2014 are going to be very powerful for what, and are already very powerful for what concerns the generation of new original images. And then, last but not least, we have transformers that are the core of the language models, and these are basically what we hear about today. About everything is going to regard language. Transformers are very powerful because thanks to transformers, we have a new way to manipulate text and to make text generation, translation, summary of text, and also image processing, but not as a GAN can do. The most famous models that belong to this group are GPT and BERT, but also Lambda. We will see in detail later, but of course, every one of us has heard about GPT. Here, just a schematic view of the core differences between the three models that we have just seen. So basically, VAA in the first column, GANs in the second, and transformers in the third. And in the last row, we can see basically the most common use cases that can be done by using one of these architectures. So moving to the Python part, I will show you how to build simple architectures by using Python for all of these three main group of models. So starting from GANs and VAA, basically we can build a very simple GAN architecture by using TensorFlow and Keras. So as we can see on the left, we basically need to import the common layers part of the TensorFlow and Keras libraries. And then, as you can see on the left, on the right, you can have basically the building of a generator model by using the sequential method that belong to Keras. You can then build the discriminator model, and then you can compile everything to have a single architecture. Then, of course, we have to put all the part that is related to the manipulation of data and so on. But just as a schematic view, the main part that compose an architecture that is a GAN are these two, generator and discriminator. That can be more complicated, of course, and you can add layers and so on the base of the complexity of the task. And in the same way, for the variational autoencoders, we can use TensorFlow as well, and here the difference is that we use convolutional neural networks in the case of VAA, and also the other difference is that instead of having a generator and a discriminator, we have an encoder and a decoder. And in the same way, we have the first architecture that is the encoder and use convolutional 2D method. And then we have the decoder that is going to use convolution 2D transpose method because this method is used to manipulate the output. And then in the same way, you can compile your model, you can train it on several epochs, and so on. Moving to large language models, here, as I said before, large language models are used for everything that is going to concern text data. And the large language models that are on the market today are basically trained on a massive amount of data. And we use them as pre-trained model, and then we can fine-tune them on our specific task. We have several examples of large language models. As I said before, GPT is the most famous one, is one of the most famous one, and is developed by OpenAI. Then there is Lambda and BERT that are developed by Google. And then there is also the Megatron Turing developed by NVIDIA. These kind of models can be used for several common tasks like chatbot or creation of contents or virtual agents that are very used today in the companies. Talking about how to use transformers and large language models with Python, one of the most famous framework, as I said before, is Hugging Face. And Hugging Face is an AI community, open source, very large. It was basically, it started to deal with the natural language process tasks, and now it's going to become, and this is already actually very famous also to deal with large language models. And the power thing of Hugging Face is that it can be used also to fine-tune pre-trained models on our own specific data. It has several capabilities, like it has tasks that are used to generate text, or it can be used to make sentiment analysis, and also it can be used to make translation of text. Here, for example, a very basic example on how to use text generation with Hugging Face transformers. Also here you can see that it's very simple because you can import from the pipeline method what you want to do, so basically the text generation, and then choose your model, and then give a prompt as an input and generate a very simple text. Of course, this is a very, very simple example, but basically starting from this very complex application can be built. In the same way, we can do also sentiment analysis, and also here we can use the proper pipeline for sentiment analysis, choose the right model that is already pre-trained and available in Hugging Face, and then also here you can put your text in and make the prediction about the sentiment of the text. And last, text translation. Also here, in a very simple way, with transformers, you can import in your pipeline the model and the method that you want to use and make translation in one of the language that your model is going to support. It seems to be, I mean, it's very simple to see here that in few lines you can build very powerful tools, but today, this is the direction that in AI we are going to take, and I will show this later also with LangChain, because basically, since today there are a lot of pre-trained algorithms, it's not like a few years ago when you had to build and train your own model and take several days to do it. Now we have a lot of pre-trained things, and we can use them out of the box, basically. So, the last topic that I want to discuss about is LangChain. LangChain is a very powerful framework designed to simplify the development of applications that are based on large language models. And the powerful thing about LangChain is that it has a very simple interface. It is modular, and it supports a lot of models based on large language, like, for example, GPT, BERT, and so on. The powerful thing about LangChain is that you can orchestrate your application and your code and spend less time to develop, but more time on the application itself and on understand what you are doing, basically. And here, a very brief example on how to use LangChain to build a very common application that is a chatbot. And here, as you have seen for transformers, for Hugging Face, the concept is very similar. With LangChain, you have to import your method and put your input text in, and basically give a response based on very simple instruction. Of course, also here you can use LangChain to make very complex stuff, but you will start from something that is not complicated to deal with. So in conclusion, Python, as usual, has a huge range of libraries that are suitable for generative AI, and it gives the possibility to build, train, and also easily use generative AI models. And it allows to cover a really wide range of use cases in this field. Thanks.
Thank you very much. There are already a few questions in Slido. And one of them, I'm going to read it. It was about I start from the first in chronological order. There was a question, it was just about the definitions. Can you define original the content generated by generative AI? Or do you think that could be like a sort of asterisk that needed there since the model can really memorize? What's your opinion about that?
Well, I mean, is original, but of course there is a bias based on what we give as input, because it's not something that goes alone without any kind of instruction. It's generated based on something that we have to give somehow as input data. So there is a bias on it, basically.
Yeah, thank you. About similar to autoencoders, also SIM, CLR have emerged from constrained learning. Could this architecture be employed as generative models? If you know about it?
Actually, I don't know about it, I have to be honest.
No problem. Do you mind to share more about the current state of the use of transformer architecture in image generation? And do you know any available model with this architecture?
Well, transformers can be used for image generation and are actually used to do it. But the point is that the way they are evolving with respect to GANs is going in the right direction, but they are not at the same level so far. So they are powerful, but they are still to be studied more.
Thank you. Could you summarize the difference between the long chain that we saw here and other libraries in the same use the same approach?
The one that I
yes.
Okay.
I think if the question is in the room, I want to specify it. Otherwise, yeah, let's take it more as a review compared to the others.
Okay. So yeah, just to hear, long chain is used more. First of all, it's used in particular for large language models and not, for example, for GANs and VAA. But it is like more something that we can use to build application and orchestrate all the piece of codes, while GANs, TensorFlow, PyTorch can be used to build architecture themselves, and Hugging Face is used to use pre-trained built architectures. So this is the main difference.
Thank you. I'd like to ask if there is any more question from the public in here. It was very comprehensive. Perhaps you want to try this library as well. How can we... There was one? Okay, sorry, there was the light in the middle.
What about retraining a model? I mean, the image one, the generative model for image generation, if we want to retrain our, for example, our personal photo. I mean, I heard about Dreamboat as a method to do that. Are there any other possibilities to do this kind of training without spending too much time or resources?
Yeah. So it's basically the same concept of using models that are in the Hugging Face community. You can find here also models that are already built on images and can be used for fine-tuning and basically make the last part of the training on your own data. So this can be done by using less computational power, of course, because you don't have to retrain everything. And basically, you have just to retrain the last layers of the model. And this can be done with any kind of set of data that you have. Of course, here in Hugging Face, but also if you use other pre-trained models, you have to choose the model that is more suitable for your task. If I have, for example, I have to make sentiment analysis, I have to use a model that is pre-trained on this kind of stuff and not a model that is used to give prediction about translation. So there is the possibility, of course. The community is very large, and Hugging Face has a lot of pre-trained model on images.
Thank you. There is a question about, have you ever implemented a stable diffusion model leveraging Python libraries?
No, this is a part that actually I never made, and it's something that I want to start to deal with.
Great, so you can get in contact. Are there any more questions from the room in here? Okay, okay, where can we find you? Where can we, if someone have follow-up question, what's the best way
LinkedIn.
to? LinkedIn.
Yeah, I think there is on the main page of the talk, I think there is the link.
Okay.
But if not, I try to put it.
Perfect. I think also through your profile and the schedule, you can find directly the LinkedIn. Okay, Serena Palazzo, thank you very much.
Thanks.
And we hope to see you next year as well. Yes. So again, a reminder, Advent for Code in Tagliatelle, just in case you're interested in that. Thank you. here. Now we will have a really interesting and important topic to talk about. Here with us, there is Adarsh Kumar, and he's also been a volunteer, so thank you so much for that as well. And he has a great background also in data science and financial, but this time in particular, we'll talk about AI and social impact using Python libraries. So Kumar, great applause for you, and please going on.
Yeah, thanks. Yeah. Yeah. So one of the questions that he often asks me is, why is it we do love superheroes a lot? Well, one thing that can be is they have superpowers. Well, if that is the case, why don't we love supervillains as well? Obviously, Joker is an exception, but still, we don't usually love supervillains. Now, the answer to this question is a very simple thing, which is they use their powers for good cause. Well, and that brings us to the quote that I just stole from yesterday, which is programming can give us superpowers. And that brings us to this. We all are here potential superheroes. We all have the potential to do something that can make a positive impact on this world. Now, you might ask is, why does it even matter? Like, why do we even want to do something good for it? But I would say that's exactly the same thing that separates us from being evil or from being bad. So why not try to use our powers as programmers in order to make something that is good, that can bring a positive change to the world? So without further ado, let's get started. Now, before getting started, something about me. I am a recent graduate from IIT Kharagpur with majors in mathematics and computing. And I'm currently working as a software engineer. And as you can see in my research works, mostly these are works that are related to interdisciplinary applications of computer science. Like, I love mixing computer science with other domains, be it medical science, be it related to social computing, or be it related to music generation as well. So I just love all of them. So now the agenda of the meeting is trying to look at the world from a bigger perspective. Exactly how? Trying to look beyond LLMs, beyond RAG, and beyond all those things which you are hearing since yesterday, and trying to look from a slightly bigger perspective, trying to think how we can use all that knowledge, all those Python tools, in order to make us impact to the world. Now, when we talk about impact, it could be in any domain you can think of. It could be in education, it could be in privacy, it could be in environment, related to environment. Even creating a small website for an NGO counts as something that you can bring out social change. Here, we will try to focus on two of the things among these. First one is healthcare, and second one is how we can use Python to fight online fake news and hate speech. So, but one question that obviously might come into the mind is, why exactly Python? And that brings us to, so yeah, it's obvious, like we have been through so many of the talks so far, we already know why Python. Well, still, if in case somebody still have that question, then here's the answer. It's because of its simplicity, because of its versatility, and more importantly, it's about its community and its libraries. How Python supports the entire ecosystem of AI and the models that we can generate around, that's exactly what makes the impact. Be it the libraries like the library that you can see, OpenCV, Hugging Face Transformers, Scikit-Image, and the obvious ones like NumPy and Pandas, and also the community forums. It's entirely an ecosystem. It's a complete system which can allow you to develop anything that you want. That's obviously some fact that I just throw in, that Python is one of the most used language. And in fact, in data science, according to some surveys by Kaggle, it is among like 80% of the people who works in data science use some or the other form of Python. Now, without further ado, let's start with the main topic, that is healthcare and medical research. Now, you might have come across all these kind of news, like about how MedGemini is creating waves in the medical world, and then how AI is being used in diagnostic world. And then there are also about using AI for better medical health care, better mental health, and how it can be used in inclusivity. Interestingly, if we try to look at the current trends, it is quite apparent that in the near future, AI is going to be used in almost most of the hospitals that we are going to see today. And basically, all this development, we can try to summarize into 3 categories. First one is accessibility. That is, how we can make the whole healthcare and medical infrastructure more accessible to the people who are remote, for those who might not have that much of access to the higher, to the more supervised people. And second one is cost effectiveness. How we can use AI and Python in order to reduce the overall cost of this whole process. And third one, we have efficiency. How we can more accurately predict that, okay, this is the disease that the person has on the basis of, let's say, their X-ray image or some other kind of image. That is exactly what the whole AI is currently working on. Now, what exactly powers this if we try to answer this question? Well, the obvious answer that comes is that Python is one of the main contenders for it. Because when we talk about AI, we obviously have to talk about Python because of numerous reasons. Well, classical ones is NumPy, Pandas for being ability to process large amount of data, as well as about these libraries like OpenCV, PyTorch, TensorFlow, which allow us to develop and deploy more and more advanced models related to diagnosis and related to supporting the medical healthcare. And also, not just that, there are some of the specific libraries which you might also want to look into, as like PyHealth, BioPython, and NLearn. These are all some of the libraries which are particularly dedicated to Python for medical healthcare. Now, it's better to understand how exactly we can apply into the real world through an example. So here's a quick example, very small example for it, how we can use it in medical history summarization. Now, it's a kind of an application which is particularly useful, which can help to reduce the amount of time that a doctor spends in basically trying to analyze the whole medical history of a patient. How we can use it? We can try to just use simple lines through using the transformers. We just have to import the pipeline and then use the summarizer, and then voila, we are done. Now, this is just a simple example. In reality, we might want it to be more inclusive. We want to have models which are much more intricate or involve more understanding of how the medical history works or how it can be summarized in a way that is complete to the doctor. Now, while there can be so many applications which I can think of related to, whether it's related to vision or it's related to NLP, like diagnostics and all, here are some of the 2 of the interesting ones that have come up recently. One of them is virtual health assistants. Now, several companies and several hospitals are also kind of adapting it in order to allow remote consultations to the patients without actually involving some doctor to go and talk to the patient. And also, this is one of my favorite ones, which is venting out companions. Let's say we just create an AI to which we can go to and just let out our heart, whatever we want to say, we can just go and say to them. These are some of the applications which we can look into. Now, coming to how we can use Python for combating online misinformation and harassment. Regarding this, allow me to tell you a story. So, a few years back, I received a call from my mother. Now, she said that while going to sleep today, you should switch off your mobile phone. I was wondering why, but there is nothing that I know of that could actually cause this. Well, she said she received a message on WhatsApp, which basically said, according to NASA and BBC, certain cosmic rays are going to come to the Earth, because of which you should switch off your mobile phone and keep it away from your body. Well, interestingly, when I tried to look up for it, it was the same post which kept on circulating since around 4 years before then, and it just kept on circulating. Somebody just started forwarding it, and it reached my mother as well. So there are so many of the posts like this which are in fact fake, but they circulate just like a virus, and nobody have any such kind of idea about whether they have to believe it or not, because they always feel like it's WhatsApp University. Obviously, it should be right. But that's not the case. So that certainly, I'll ask us something needs to be done. Now, similarly, take another case. Let's say one fine morning you wake up and you start checking your social media account, let's say X. And the moment you open it, all the posts that you are seeing are something about using some cuss words about other people, using some hate speech. Do you know how would that experience be? Well, I'm telling you, it's not at all a great experience, because I have worked with annotation of hate speech. And that is horrible experience. It not only just leads to a mental disturbance, but at the same time, all this misinformation, all this hate speech, it just leads to an impalement of our own ideas about what's exactly good and what's bad. We might, at some times, if we see a hate speech, we might, if we want to support it, we might still be thinking, okay, even though it's hate speech, since it supports my idea, it's good. But that's actually impairing how we know what's exactly right, what's not. And regarding the fake news, it impels how we can actually try to understand what is true and what's not. We no longer have an understanding, should we believe it or should we not? So that's exactly why. Now, don't worry, because we have Python here for the rescue. It has immense applications into this domain. Particularly, like, for example, if we look at regarding the fake news one, we have systems like fake news detection systems, fact-checking bots, and social media monitoring. These kind of systems allow you to remain safe from all these kind of mess up coming on your feed and trying to disturb you mentally. And also, on the side of hate speech detection, we again have several applications like hate speech detection, counter-speech generation, hate word masking, through which you don't have to go through all those things. That's exactly where Python comes to the picture. Now, again, taking an example, we have an example of, let's say we have two samples, which is one of them is about hate speech, another one is not so much hate speech, but rather about opposing some idea. Now, we can use some, again, using the pipeline, trying to import a classification model for toxicity detection, and then just inserting the sample that you want to classify, we are done. Basically, that's much simple it is with Python to classify whether a sentence is toxic or not. We can easily use that or deploy that into the systems like all those social media platforms and try to avoid people from getting exposed to all those kind of hate speech. Now, it would be an injustice to not to mention Hugging Face here, because it is because of the Hugging Face that we are able to actually access all these kind of models. In fact, like regarding the models, how much it offers, Hugging Face offers around 1,300 samples related to hate speech, 1,300 models, and 400 models related to fake news. And then there are also organizations like Hate Speech Synergy, which particularly works in the domain of hate speech detection and mitigation, how we can mitigate it. This is, in fact, one of the organizations which I worked with some time back. So this brings us to a very small question about us. Like, everything is fine. We have seen through many applications. We have seen through how to use it, how everything. Now the question comes is where we can start. Well, to this, I would say a very simple thing to do is just choose a domain, look out for a problem you want to solve, and think about how you can use Python to solve it. This third part is, in fact, an interesting one. It relates to one of the common challenges. Now, let me tell you about it. Let's say you create a kind of a chatbot which allows you to tell what disease you have, what problem you have on the basis of the symptoms that you describe. But the problem is that we as humans tend to believe more on what humans say or what humans do rather than a machine do. But in fact, howsoever reliable it is, even if the human is not so much experienced about it, about healthcare, but if the human says it, it becomes more and more reliable. We want to believe in it, even if it's not true. But when it comes to machine, it's not the case. So that's exactly where I would emphasize on trying to come up with methods through which AI and humans can coexist. Let's say we don't want to actually advise user about what disease they have on the basis of their symptoms, but rather allow a system to assist an actual doctor in order to assist the people. That way, we can create a more reliable and more a system where humans and AI can coexist and try to support the whole system rather than not in a deteriorating way, but rather in a constructive way. And that brings us to the end of this talk. And before even asking you questions, I would like to ask you a question. It's more of a point of wondering, can you think of ways in which we can use AI and Python in order to revolutionize the education system? How we can think of ways through which it can help the way we see education today, how it can change. I do have some answers, but probably I would love to talk to you if you want to share. Yeah. Thanks. That's it. Yeah.
Thank Thank you very much. Ardash, and do you have any question for the public in here in the room at the moment? I'd like to ask you a question, actually. If you have any suggestion on how to choose a cause of reference to start a social impact project, because there are so many, unfortunately, issues to be solved. So in your opinion, it's better to stick to the things that we know, or maybe also the things that, as you mentioned, maybe we don't know a solution already, but we're passionate about. So what will be your pros in choosing?
Okay, so, well, I would say the way how I would approach it if I had been in this scenario is that I will try to do the mix of both. I will first of all try to look for domains where my expertise lie. And then once I have shortened down to the domain where my expertise is, I will try to look for the recent problems that the research papers that are being published in that are trying to solve. Like one of the reasons why I started working on hate speech was when I connected with a professor in my college. He was working in this. And the more papers I read through, I realized that there are problems. There are more problems. The more recent paper you come up with, try to come across, the more interesting problems they try to tell you that, okay, this is the direction you can try to work in. Like, in fact, the thing was that when I started working on the project, I was initially working on hate speech, but later on, I published a paper which was on counter-speech generation, which can be more empathetic. Because that was a problem which was supposed to be solved, because already there were so many people working in hate speech, but counter-speech is still something that has been unsolved. So probably looking into that direction, yeah, that's how I usually proceed. Research papers, yeah.
Thank you. Yeah. Do you see a sort of this approach can be used also like in university? As you're a university graduate, I guess you have more in contact with university, and sometimes what I also try to do is more project, social impact project inside university. Perhaps it's something that you can see it happening, or I know the students are already quite busy, so your approach could be more addressing the student themselves, or eventually the professor that can lead to, I don't know, using more data science. Personally, I use more data sets already on social impact, so if the students are researching and exploring data set, can spark their mind, but I'd love to hear your opinion on that.
So exactly like in, can you just
to have a more social impact project in university, if these come to be more addressing the students or the professor themselves, or if you have any experience in what direction for your experience or suggestions.
Okay, so basically about how we can, how it has been evolving over the years, you mean? The projects, how they have been evolving.
Yeah, and also how to have more social impact project inside university also in the future.
Okay. Not that I understand it completely, but I would say like I'm not really sure about the question, like exactly. I would say like.
Frame it if you want.
Sorry.
So basically, let's say a computer science university. Usually, the projects are quite simple and strictly to the education, learning the libraries, but not so many times are connected with social impact. For example, we saw with machine learning, we see the dataset means of the digits. But perhaps the dataset used and the problem to solve could probably already be in the direction of social impact.
Okay. So yeah, in that what I would say is like it depends. Again, it depends, like, because there are professors that actually work on something that is related to social impact, and then there are professors who are not. Now it depends on the student who is going to attempt on that particular problem. Like in my case, when I started, one of the problem statement that I worked through along with talking to the professor was try to participate in a shared task, which is basically in a workshop. So that could be a way to start. If you don't have a professor who is exactly working in social impact domain, then probably you can just take up any workshop which works in social impact domain and start doing a shared task probably. That would be the good start, I would say, for the students. For professor side, I would say is like, it depends on their expertise level, because still in this particular domain there is a lot of competition, at least in terms that who wants to produce more such kind of work which is more citable or more relevant to the real world. That is still something that comes with experience. So yeah, that is certainly there.
That's actually true. So I was wondering if there is any more question or even the social impact project that we want to share.
You talked about medical application. I tried in my career to do something like that, but I had a lot of problem with privacy, with data. Did you ever had such problems?
Okay. So, well, most of the time when the data set that I worked with, they were usually the ones which have been like personal data has been removed from it. Like one of the problems that I worked with was related to self-reported breast cancer detection from tweets. Now that is an interesting problem, but most of the time it is, since it is curated by humans, so usually the information is removed manually. However, like given how fast it is increasing, it's still like something that problem needs to be solved, because always you can't rely on machines ever for just for the sake of like it can remove the data, but how can you actually like make the government comply with that? That is always going to be an issue. At least for right now, it's not a solvable part. Most of the times I worked on data which is smaller, though smaller, but still at least it's reliably good in a sense like don't have personal data. So yeah.
Thank you. There is any more questions or sharing? Okay, where can we? Oh, thank you. Sorry.
Since no other questions, I just wanted to ask, like, it looks very interesting from a research point of view and to implement it, but how would you like go about really implementing it? Because all the news platforms or the media platforms, it's like Twitter, Facebook, they are doing their own systems.
Yes.
And that is the channel for people to hear news. So how do you make an impact in terms of making sure that people get the results of your, you know,
Okay.
hard work?
I would
or
say
maybe there are some social projects that one can contribute to which are actually connected to the front end where it's delivered.
Okay, so well, I won't say that every one of those social media platforms has a way to do it, because like, let's say WhatsApp, it is end-to-end encrypted. So even if some post is getting circulated, unless and until somebody reports it, it's very hard to track it down. But I would say an easiest way to do it is, let's say I just create a platform where people can go and post the, just paste the post, whichever you have received. And let's say this post is now, since we have more advanced models or like agents, AI agents, so we can, let's say, some agent which has access to the more recent news related to a particular domain. Let's say it just accesses that in the background, retrieves it, and on the ground of that, it tries to tell you whether this fact is true or not. It can be an add-on feature for now, as long as they are not open to it, because usually how it works is that research publishes something, then the companies also try to include that themselves as well, because they are also people who are concerned about all these increasing problems. From a free open source perspective, I would say like just creating something where people can just go and check for the fact or something like that. Those kind of projects will also work out. Yeah. Yeah.
Thank you. Can you show again where can we find you for further questions?
Sure.
Best way to connect with you?
I mean,
don't worry. You can tell us.
Yeah, you can
perfect.
mail
Okay.
me. You can email me, or as well as like. I guess that's the best way.
That's the best way, right?
That's the best way. Let's just stop it there.
Okay,
Yeah.
perfect. So thank you very much, Ardash,
thanks.
again.
Okay, thanks.
Okay, our next talk will be at 4:20. So feel free to change your room or stick around here, and see you very soon. Have you noticed that there is a nice chart of Italy in front of the registration desk? Did you put your point if you're in Italy for the PyCon community? Would you like to join one? No, here with us we have Luca Gilli. He's CTO of Clearbox AI. Clearbox AI is a great company in Turin. They work with synthetic data. They were very helpful in supporting also Python Torino, Northwest Italy community, and also the data beers. Also yesterday, thank you for the support if you've been the data beers. But especially today, Luca Gilli will talk about the role of data scientists in the future implementation of the EU AI Act. That we talk about also finally, it seems pretty concrete. So Luca Gilli, please enlighten us what the role of data scientists in all of this. Thank you very much.
Thank you. Thank you, Stefania. Can you hear me? Is the mic working? Yes. Great. My objective today is to share also my learning process during the last few years, because I've been following the topic of the AI Act, or in general, regulating AI for a while now, and to try to give you a perspective. So the perspective is a perspective of a data scientist. It's a very incomplete perspective, but what can I do in 25 minutes? I will try to include. It's fresh off the press. A few days ago, actually 3 days ago, the EU Council approved the AI Act. So this was the final green light for this new regulation. It's officially a law from now. It's been a discussion which has been going on for years. Probably if you've been following the topic, you heard about regulating AI already for a few years. Right now, we are just waiting for the publication in the EU journal, but it's official. But it's something that started already some time back, before the advent of large language models, maybe when we were still talking a lot about deep learning. They started talking about regulating this kind of systems. There has been a lot of negotiations, a lot of iterations, a lot of modifications in this process. And of course, most important, there has been ChatGPT and large language models. So what was drafted, what was reached as an agreement until 2021 was completely blown apart by the advent of large language models. So the EU itself had to do a lot of running after technology in order to keep up to date with this new, what was happening in the technological world. But the most important part is that what do we define as an AI system? That was also, there was a lot of discussion and negotiation about it, because it's the most important definition. Eventually, the EU decided not to draft a new definition of AI, but to follow what the OECD is saying about AI, so the Organization for the Economic Cooperation and Development. And they decided, okay, from now on, we'll take this definition of an AI system to decide what falls into the new regulation. And this definition defines AI as a system that operates according to a certain objective, and takes some input in a virtual or in a real environment, and transforms this input in an output that could be a prediction or recommendation, an indication on how to follow up on a decision. This definition is very broad. It doesn't cover just machine learning, but covers many more other systems, and it's also a complication. It's something that can be applied, for example, to rule-based systems, for example. But it's a definition that from now on will be used to define what falls into the new regulation. They also had to make a new distinction last year about traditional AI models versus general purpose models. Until last year, they were talking about traditional models, so models that are trained to perform a specific task. So most common machine learning models are trained to solve a very vertical task, like predict the breaking of a machinery, or decide whether an X-ray presents a disease or not. These are defined as traditional AI models, and certain rules applies to these models, but they had to introduce a new definition of general purpose AI, which are models based on a concept of pre-training, and models that are used on a more broader scope. So for example, AI assistants. they created GPT on a pre-trained with a pre-trained approach. They didn't have a specific task in mind. People are using ChatGPT for different reasons, to help with coding or to help with summarization. There's no specific task, and this defines a new family of systems, this general purpose. So there's this big distinction. Today we'll talk about category 1 mainly, because it's also the one which is more regulated. And the most important aspect that the AI Act introduced is this pyramid of risk definitions. So they decided, okay, we defined what's an AI system. We defined also where these systems operate. There can be different categories where the system can operate according to certain risk levels. So they defined initially 4 levels of risk. And then they added this lower step of the pyramid after ChatGPT, based on what is the risk associated with undesired behavior with this machine in the kind of system, in the kind of context. So first of all, they defined some categories that are defined as unacceptable risk. So from now on, these categories are not allowed in the AI world. We decided that there are some conditions where AI systems shouldn't be operating. They defined these high-risk systems, where are systems that operate in conditions where a wrong output of an AI system can have bad consequences on people's life, basically. And then they defined systems associated with lower risk that require less attention. And at the bottom, they also created a separate category, as I was talking before, about general purpose AI. So a different kind of attention dedicated to this system. I'm talking about regulation, but I forgot to say that this is, first I said, the first comprehensive regulation, because this is the first time we are trying to have a comprehensive approach to this problem. That doesn't mean that regulation doesn't exist. There is already some regulation in place about AI. For example, the GDPR states that you can do or you cannot do something when AI systems interact with people's life. In other countries, there are some very vertical or very specific regulation about AI. For example, in the state of New York, they are adopting some constraints or some limitations on what AI system cannot and can do. But this kind of risk-based definition, this kind of approach is the first time we are trying to tackle the problem in a very comprehensive way. So what happens, first of all, what happens with prohibited systems, with this unacceptable risk? From now on, we cannot use these systems anymore. The EU decided that there are some categories, some working conditions that are not acceptable anymore for AI systems. And these are categories such as social scoring. We cannot use AI to give a score to citizens in Europe. We cannot use AI to categorize citizens based on biometry. We cannot use AI working on facial recognition databases. This is not straightforward. Like in other places in the world, these applications are allowed. So from now on, in Europe, this won't be allowed. So from now on, I mean, from 6 months from now, this application will be forbidden. So we cannot even think about using it. And the most complicated part comes with high-risk systems. So systems that are working in conditions where bad choices or bad predictions for the models can have severe consequences on peoples and on infrastructure. So this new regulation defined some categories that will fall into this on this step of the pyramid, categories such as systems working with critical infrastructure, so with transportation or energy, system working in training or education, or system working in safety in general. So whenever there is the risk of having severe consequences on some AI misbehavior, this is categorized as a high-risk system. And this, in the regulation, is the most complex part, because the new regulation defines a lot of requirements that this kind of AI systems need to fulfill in order to be used in the EU from now on. And they defined a list of requirements. These are technical requirements of these systems. that will need to be demonstrated in what's called a conformity assessment. So we have some technical requirements. From now on, companies working with high-risk systems will have to create this conformity assessment, which is an evaluation process that will demonstrate that these systems fulfill all these requirements. And these requirements are very broad. They are requirements about how we are documenting our system, how we're writing technical documentation. There are requirements about how we prepared and curated the data, how we defined, how we divided the data into training, validation, and test. Requirements about how also we deal with risk associated with the systems, because in any risk-based approach, we cannot simply assume that the risk is zero. We have to estimate what is the risk of something bad happening, and also to define what is the strategy of our response to these events. So it's very technical. For example, they talk about robustness, accuracy, and cybersecurity. These are very technical terms. So if we talk about robustness, it's a term which is grounded mathematically. We have a mathematical definition of what a robust system is. Unfortunately, until now, the definition in the regulation is very high level. There is no technical definition of what do we mean with an accurate or a robust system. The intention is in the next coming 1 or 2 years to also to come up with a standardization. So we have a requirement, how do we fulfill this requirement? And this might vary a lot depending on the vertical we are operating. So a system working in the medical field might have different requirements than a system working in the educational field. The problem here is that creating this kind of conformity assessments is a process that involves different stakeholders. So there might be people working on the model, data scientists or data engineers. There might be project managers. So some people asking for a business need to be solved, understanding what is, for example, also the consequence of a bad decision of a system. So it's a situation where we have different people interacting with each other with different expertise and with different expectations about an AI system. And the question, in my opinion, the most interesting question was that what is going to be the role of a data scientist in this context? And it's very difficult to give an answer in the next 10 minutes, but I recommend reading this paper, which was authored by Professor Floridi from, back then he was at the University of Oxford, but now he's in Yale. And it's a procedure to perform conformity assessments. It's still a bit high level, but it's the first time I managed to read something that was also referencing some technical solutions about how to fulfill these requirements. And in this paper, for me, it's quite interesting because they do mention what are the different stakeholders in an AI system, and they do mention what are the responsibilities of a data scientist among the other stakeholders. And in this paper, they say that the data scientists are responsible for documenting how the system, the AI model is performing with respect to the training and the testing environment, so the training and the testing data. They have to justify what was the process leading to the final design of the system. So what was the based on deciding what are the best hyperparameters, for example, if you are using a machine learning model that have been chosen and define the system as is. And most of all, they have to identify what are the breaking points of the system, because remember, we are talking about risk analysis. We have to define what can go wrong in our system, and when we define what can go wrong, somebody else, for example, another stakeholder, a risk expert, might decide what can we do when things go wrong. But the role of a data scientist is to find what are the failure patterns of a model. And it's not an easy task, and in my opinion, I would argue that this boils down to a problem that many data scientists know about machine learning, which is the black box issue. So as systems become more and more complex, understanding how do they behave is becoming more and more challenging. it's often called the black box problem because we might have a system like a neural network that gives very accurate answers and without giving the user or even the developer an answer about how they came up with this decision. And in a context of risk analysis, this is a problem because we want to understand how the machine operates and what are possible failure points, and what are possible situations when the machine is not good to operate. In literature, there are a lot of references on how to do what we call a model assessment or model auditing. So we do train a machine learning model, we do analyze this model from a global point of view, but we also want to understand what are the local characteristics of this model. There is a lot of literature and a lot of methodologies also coming from academia. Of course, we are at a Python conference, so I think I'm contractually obliged to talk about Python in this talk. There's a lot of libraries and a lot of interesting material. Today I decided to talk about a library. It's called DeepChecks. I don't know if you've ever heard about it. I'm not affiliated in any way with this library. It's an open source library. I think it's quite interesting because it creates some kind of boilerplate for what does it mean to validate and to analyze a model. It's open source. It can be applied to different kind of models and data sets, from tabular to image to text. And on the long term, I don't think people should use this library to do conformity assessments, but for me it's educational because it's based on a very automated, it has a very automated focus. So the idea is to create this kind of validation test as automatically as possible. And this kind of automated process also can give a lot of ideas about what could be interesting tests. Even if you want to learn about how to do model validation, I think it's a good way to check what this library is doing and maybe take some inspiration. And I wanted to show you some practical example from a notebook. I picked a toy dataset, a toy problem. A dataset from the Lending Club dataset. Maybe you heard about it. It's a dataset where a model should be trained to predict the risk of lending money to a certain individual. It's a binary classification task. So we have a target column called default, which tells if this individual after a certain point of time was not able to repay the loan. And the model should make a decision based on characteristics of the application for this loan. For example, they might ask for a certain amount of money. They might ask for a different time spent to repay the loan. They might have a different income. So it's a fairly simple toy dataset. Let's say it's quite interesting because it's already a dataset containing numerical columns rather than categorical columns. And whenever we are working with tabular data, right now, the model to go is a model based on gradient boosting. In this case, in this example, I'm using CatBoost, which is a model based on boosted trees, which has a very nice advantage of dealing internally with categorical columns. So whenever there is a categorical label, as long as I provide the model with information about this categorical label, the model knows how to tackle this aspect. This is just a toy problem, so it's not nothing really tuned or nothing particularly not a super performing model. It's just a reference to show you these deep checks. But after fitting the model, we might want to test it on a test data set and see some kind of global metric. So we see that it's a binary classification where the default label luckily is much rarer than people being able to repay the loan. It's a model which is going okay. There's a decent precision and a fairly low recall. I didn't do much to improve this model. The idea here is to show you how can we go deeper into analyzing this model. So usually what we do, we might look at the feature importance, how much importance the model is giving to every single feature, and that's quite easy because we are using a boosted tree approach, and that's some information we already have inherently with the model. But the most interesting part, and I will just skip to deep checks, is to use this library, which is a library that tries to automate what are the most important checks that we need to apply to a model to validate it. And to import it, we just have to create this dataset class that takes a pandas data frame as an input. We can specify which is the target column and what are the categorical columns, so the columns that are associated with a categorical label. This tool can do a dataset analysis, and I won't go through it now because of time. The most interesting part is that it can do a model evaluation. So provided that we define what is the trained dataset and the test dataset, we can feed a classifier. It accepts any kind of scikit-learn-based API or XGBoost or CatBoost. And it automatically generates a report containing a lot of different tests. And this report can be saved in an HTML file. And it's a report that contains a lot of different tests that have been applied to the model. Most of these tests will pass. Some of these tests won't pass. And I wanted to show you an example of a test that didn't pass because I found it particularly interesting. So here it performs a test called weak cement analysis. And what it does, it automatically divides the data set in data segments, trying to understand where the model is more likely to fail. So internally, they have a library to take the data set, define some intervals for numerical columns or groups of categories for categorical columns, and it automatically divides the data in these segments, understanding whether there are some portions of the data where the model is going better or worse. So in this case, one of the tests that didn't pass is the fact that the model might have a global accuracy, which is decent. But then if you try to break the data set in different segments, you notice that for some kind of data points, the model will work much better. And for other kinds of data points, the model will work much worse. And this is very interesting because this kind of analysis, for example, tell us that for people who applied for long 60 months, the model is doing much worse than for people who applied for 36 months loan. And that's a very useful information because we might understand that the model is not designed to work properly in this kind of interval. So, for example, for low-income people with loans for after longer than a certain length. And this information is something that a data scientist can collect and package and provide to somebody who will then make a decision about what to do with this information. So they might say, okay, I won't use the model for this kind of population, or I will do something else to mitigate the risk of the model not working very well for this population. This analysis is also very interesting in terms of bias and fairness. I won't have time to talk about it today, but we could do the same analysis for, instead of talking about categorical features in general, about population segments in terms of protected categories. So we might understand that the model is working worse for females rather than males, or younger people rather than other people, and that's a very precious information. And this is a very short example. I would recommend to have a look at the library just because it gives a nice introduction. I just wanted to conclude because there's a lot of talking about whether this kind of regulation is useful or not in terms of competitivity of Europe compared to other continents. They say that having too much regulation might slow down progress in AI. I would say that this kind of conformity assessments, at least, is quite important because it's something that all data scientists should do. It's something that has a lot of value, especially considering what are the statistics in terms of machine learning. They say that among a lot of R&D and a lot of projects are being organized and funded to investigate how to use AI, but only a small portion of them actually become tools that are used in production, that are used in real life. And one case particularly important is in medicine. There's a concept of translational medicine where we want to transform what we do as research in academia into something which is really used in real life. And recently, there's a lot of talking about the fact that the great majority of research in AI medicine doesn't even reach clinical studies. And there are a lot of papers that started studying this phenomenon. For example, papers that have analyzed all the papers that have been published during COVID about creating the best model to detect lung COVID diseases based on radiographies. And these papers are always fundamentally flawed. They always have problems such as data leakage, lack of interpretability, lack of understanding how the data was prepared and curated, which made the models and the research effectively useless. So in this case, doing this kind of conformity assessment would have been something that could have transformed something which was pure research in something that had much more potential to become something useful. Concluding, will the AI Act is now law. By 6 months from now, prohibited system won't be allowed anymore. High-risk system will be regulated 3 years from now, so we have this kind of buffer time to understand also technically what does it mean to do conformity assessments from a technical point of view. But they're going to be interesting times because it is a law, but we still have to define all the details and all the important aspects about what does it mean to understand AI systems in this kind of context. And I will conclude within 25 minutes. So, okay.
Perfect.
Thank you.
Thank you very much, Luca. We have a few questions. First of all, one thing that you just mentioned about the deadline. What about the fines? In particular, what are the fines or penalties in case you don't fulfill the AI Act requirements? And if you have I read something, I'll let you.
I don't remember the numbers, but it's like the GDPR. So it's a percentage of, it's either the maximum between the percentage of the revenue of a company and a certain amount. And it varies according whether you're using a prohibited system or misusing a high-risk system, but I don't remember the numbers there.
Yeah, I can say for the ones I'm quite vital, they go to millions. For high risk it's way less. Yeah, thank you. Yeah. What happens, so in particular this is connected, so what happens if the users of the system, not their development, if they don't comply? I guess is similar questions. I don't know if you want to add something in this reframe of the question.
Maybe an interesting detail that I forgot to mention is that for high-risk system, all these conformity assessments are self-assessment. So for most of them, there are some systems where there should be some notified body checking on these assessments, but most of them will be self-assessment. So it's like basically like GDPR. You might, like as for data, you need to do like a data privacy impact assessment, and then there might be some inspection. With AI Act, you will have to prepare this kind of reports, and then eventually you might get checked and pay the consequences of not doing it if you're busted.
We hope people will enough education to be able to self-assess, but this will be a great start. And do you know if for the AI CV screening model, they will fall in the high-risk system regardless their complexity?
Yes, I think so. It's because if they're simpler models, then it will be much easier to demonstrate that there are very low risks associated with the model. If you have like a rule-based system, then it's straightforward to do a conformity assessment. But HR is really one of the categories where it will be mandatory to these self-assessments.
I read the question directly. What about transparency risks for LLM? You mentioned them in the pyramid, but I would be interested to know more about the data scientist perspective of them. So you, in this case.
Yeah, it's first of all, going back in time, they included this category of the chatbots before ChatGPT. They thought chatbots were very harmless systems where the only requirement was to specify somewhere that the user was interacting with an AI system. That's still the case for most of general purpose AI models. So depending on the context, like they created this this separate category for a GPI, and depending on how they are used, because even language models can be used in different contexts, and different contexts will have different risks associated with them. But if you are operating with a large language model in a high-risk setting, you will have also to demonstrate some not the same requirements of the that I showed before, but another set of requirements such as robustness to adversarial attacks, robustness to poisoning, and so there is another list that I didn't mention today. But
yes, thank you. There is a question in particular for the deep check, sorry. Fairness and deep check deals somehow with infrequent classes, and in particular. If not, it would be interesting returning an output, like not enough data points to assess fairness. And also some compliments for your talks, if you can expand more on fairness, if you mind.
I think deep checks might have the limitation that when you have a system which is automated, you lose in freedom of using it in a customized way. It can handle, for example, when dealing with rare labels, either in the input or in the output. In the input, it has an automated way of handling. It groups all the rare labels in a single other category. And for outputs, you can specify your own custom metrics to measure this kind of specific metrics. And for fairness, deep checks is not really the library to go to measure fairness. I think it's my idea is that this kind of segment analysis is the way to go, because it's already what other tools that are completely dedicated to fairness are doing, like Equitas or Fairness 360. They divide the data in protected segments, like depending on the context. Like if you're in a medical domain, you might be interested in checking what is the model doing with respect to different age ranges, or and they analyze that the model is performing equally in these segments. So you might be interested in a model that doesn't make more mistakes for a gender rather than the other, for example. But this kind of segmentation is maybe deep checks is not the best way to do fairness analysis, but fairness analysis is usually based on segmentation.
Yeah. Thank you, and thank you also for mentioning the other libraries on fairness as well. There was one question, a quick question. Deep check could work also. We mentioned LLM, but in general, could work with deep learning also more in general, right?
Yeah. I never used it for images, but I saw that there is a module for images as well.
There was a peculiar question about, do you think, in your opinion, that this regulation could be more an opportunity for lawyers in data science, or due to the importance of governments, is a matter of fact? I'll let you reply to that.
No, it's an interesting question. I think there's a strong analogy with GDPR, right? Sometimes GDPR can be perceived as a pain because we have to put a lot of layers on what we cannot do with data. We have a lot of DPOs always shouting at us about how not to use the data. But at the end of the day, it's also useful for us as citizens, because it's a way of protecting our rights, and I think we benefited from GDPR compared to other countries. My feeling is that it will be the same for the AI Act.
Thank you. Yeah, in this age, we saw a lot of regulation that came to be quite spread from China to US to EU finally. So EU probably is the stronger and more stable for now. And something that could be very interesting to hear your opinion about regarding this regulation, which is the best way to leverage and gain value from synthetic data?
That's a very good question.
Challenging to address.
First of all, the AI Act talks about regulatory sandboxes, so the platforms where organizations can experiment with models and with AI systems, and explicitly mention synthetic data in this kind of situation, like to create this kind of test beds for models. And in our experience, also in our startup experience, once you identify a bias with a data set, a bias with a data set that propagates to the model, synthetic data can be really useful in mitigating this bias. So once you identify the problem, to inject your own expertise or your own requirements about how the data should look, and therefore the model.
Thank you very much. Can you show again where we can get in touch, just thinking for further, which one do you think is best? Email?
Yeah, email
probably.
usually, yes.
Yeah, okay. So for the question, yeah, very last quick questions.
When speaking about prohibition, what exactly is going to be prohibited? How do we identify the models?
There's a very detailed article about what are prohibited systems. Basically, you can find a checklist that will tell you whether the system is okay or not. But usually, I think this covers 90% of the categories mentioned. So if
do you mind to talk together after this? We have the time that we have for now. So thank you very much, Luca, and
thank you.
Now I kindly ask you to chat with Luca about slowly go out of this building and versus the coffee break and then the keynote. And thank you very much.